does that saying go? One part number to rule them all, one part number to find them, one part number to bring them all, and in the IoT connectivity bind them. Nope. I think that's pretty close to a quote about a ring and some hobbits named Baggins, actually. Right, but if, my friends, you are building a connected ring, perhaps one that needs cellular connectivity, and say you want to sell this ring all around the world, what then? Well, you're gonna need to do a lot of legwork to get all of those certifications. Never mind avoiding all of those orcs and assorted bad guys. And maybe you don't have an army of engineers looking into the various cloud connectivity and sensor options out there. And don't even get me started with all of that RF black magic we're gonna have to do. And trying to match up all those different part numbers? Phew. Isn't there a wizard somewhere around here that could help me out? Jeez. Does IoT with cellular connectivity really have to be this hard? No. No, it does not. Hi, I'm Amelia Dalton, host of Chalk Talk. Yes, in this episode of Chalk Talk, I sit down with Jason Chien from Renesas and talk all about the various hoops or rings, you might say, we're going to have to jump through to get global cellular connectivity into our next device, and how the Renesas Synergy AE-Cloud2 development kit can make all of that pain go away. Poof. And spoiler alert, the good guys totally win, so there you go. And before we get started, don't forget to click that link. There you can find more information about the Renesas Synergy AE-Cloud2 development kit. Hi, Jason. Thank you so much for joining me.
Thanks for having me here today, Amelia. It's been really great to be here, and I'm looking forward to being part of this Chalk Talk and looking forward to get started today.
So in my IoT designs, one of my biggest challenges is when I need cellular connectivity. So I'd like to talk about what is required and what it looks like to put cellular connectivity into an IoT device.
That's a great question, Amelia. So in general for IoT, when people think about connectivity, one of the things they've always desired for, if you sat down with anyone and said, hey, from scratch, give me your ideal connectivity, people would describe it as having long range. You could go anywhere you want with it. Be anywhere, wireless, cordless, boundless, go where you need to go. They would also describe it having as a long battery life, because we've all had experience of our phone running out of charge at the airport, not having enough juice. So battery life is always very critical. And also cost. In the 60s, we sent a man to the moon, but obviously that's not something every mom and pop could do. So we need the cost to be something that people can attain and get to. So that's when we talk about ideal connectivity for IoT.
So how is cellular IoT different than cellular we're used to with voice applications with cell phones and stuff?
A lot of times today, we're all used to our cell phones. That's the most common way people have access cellular, the most comfortable with. We all have smartphones. We're all connected. We're all hyper-wired, as they called it. And, for those of us that still make phone calls, those of us that are of the age that would actually make phone calls these days, the way a phone call works is, if you're driving home in your car, typically you're going to call, home, you're running late and say, hey, I'm on my way home. From your car, the signal, from your cell phone gets sent to the cell tower. Cell tower relays and transmits that to your house, your landline, if someone has a landline still, or another phone, and says, your person on the line says, okay, great, I'll see you soon. So a lot of things have to happen. Number one is you're moving in the car. And so the phone has to be able to track the location to the cell tower. And also the quality is highly important, that if you misplace one of the words and scramble the words, you get static or you get a drop call. So it's very critical that the signal coming from the mobile phone to the tower is high quality, high reliability. That's what you're paying your 40, 50, 100, God forbid, hundreds of dollars a month for, on your family plan or so on. But when we come to IoT, it changes a little bit, because now instead of a person talking on the phone, we have an electronic device that's sending data, bits and bytes to a server in the cloud. And when it comes to that data, the game changes a little bit. Now, definitely the high reliability, high quality pipeline that uses to send your voice data certainly could use that for data from your devices. But the challenge is you don't necessarily need that. And that's something that a lot of embedded developers and even the mobile carriers have started to figure out, that actually we don't need such a sort of premium, quality for the kind of information that we're sending. If a device has a sensor data to update, like temperature or humidity, if it doesn't send you can just retransmit it. It's not critical. You won't get static. You just resend the signal. So the need for that reliability has kind of shifted the use case for cellular and IoT.
Got it. Okay, so what are the things that engineers need to think about with their cellular IoT applications? Now, you mentioned speed, battery life, and quality of connection.
Yeah, so in general for cellular, specifically LTE, there's a range of technologies that are used. One is, we're all familiar with LTE Advanced, which has speeds up to greater than 10 megabits per second. So we talked about the high speed. And the cellular carriers have responded by rolling out some new cellular technologies, such as LTE-Cat1, and then Cat-M1 and Cat-NB1, that basically make some trade-offs that can help and benefit embedded developers and IoT devices that can address some of the things we talked about. So in terms of speed, again, a lot of IoT devices, we're not streaming videos or doing voice calls. We're basically sending sensor data or bits and bytes. So you don't need the highest speed connection. Also, in terms of the battery life we mentioned, part of the reason the cellular voice calls consume while your phone runs out of battery is in order to maintain that highly reliable connection, you need the phone to basically constantly be checking with the cell tower and maintaining that signal. So it constantly needs to be awake, transmitting, and sending information back and forth to maintain that quality of a connection. A lot of the new cellular technologies for IoT, Cat-M1 and Cat-NB1 specifically, the way they achieve that, a lot of the times the devices can go to sleep because sometimes you're not constantly sending sensor data. Maybe you only need to wake up periodically and send that information. So that's a way you can conserve battery life. Number one, you're not constantly roaming and searching for the best cell tower to connect to. You're not constantly trying to optimize the signal quality because you're trying to transmit voice data. Again, we talked about you can retransmit sensor data if you drop anything. And then also the devices have the ability to go to sleep and then maybe only wake up and transmit when needed, or do other operations and only turn on the cellular radio as needed. And some of that is seen in some of the applications that for cellular. So things like mobile devices and connected cars, those are again in the category of high quality, high reliability connection. We start to shift to other applications like, smart utilities, asset tracking, smart infrastructure, smart cities. Again, the utility meter on your house doesn't necessarily need to transmit every second, every time you get a new update. Once a day or even a couple times a day at most is probably more than enough. Actually, for your power company, most probably prefer you never send the data so you never have to pay the bill, but that's not the world we live in. So there you go. So that's a little bit of the landscape of the different LTE and cellular applications.
Okay, that makes sense. Now let's dive in and talk specifically about what Renesas offers here. Now, how do you help me get started in this cellular IoT world?
So to help a lot of embedded developers, we have put together and launched a kit we call the AE-Cloud2 kit. And some of that is we view it as all the pieces you would need to help build and start your cellular embedded IoT application. At the heart of it is we have a Renesas Synergy S5D9 microcontroller board, and included in the kit is a Wi-Fi PMOD and a cellular Arduino shield, and also some of the accessories you'll need like various cables and antennas, all that you need to get started to build that initial application, as you can see here on the slide.
Can we focus in on the board part first? What's on there and how can I expand it with sensors or shields or whatever things I can add?
So at the heart of the board is the Renesas Synergy S5D9 microcontroller board, and in there is included obviously the Renesas Synergy S5D9 microcontroller. We also have a Renesas ambient light sensor. So some boards and kits out there, you can have a board that has a microcontroller on it, but what's missing is, you wanted to do any kind of sensing of your environment. I'm sorry, you'll have to go buy some accessories. It's kind of a little bit like you get the bare bones, and if you want, did you want anything else on top of that? Well, that's a little bit extra. So this kit includes sensors such as microphone, environmental, temperature, humidity, kind of all that good stuff, accelerometer, magnetometer, so you can sense direction, position, movement, environmental conditions. So a whole host of sensors that are kind of included in there. And that is a great starting point. But in addition, also, we recognize that because we didn't want this kit to be $1 million, we couldn't jam every sensor possible. So we know that there are other sensors out there that people want to do that aren't going to be included. So to address that, the board can be expanded. So we have connectors for PMOD and Grove as well too, and also a JTAG connector for those that want to connect and interface in that way. And also there's an Arduino shield, and also we have 2 USB ports that you can access the device for a command line interface. And also there's a built-in Ethernet PHY chip, so Ethernet built right into the board right there.
Okay, cool. Now I see I have a lot of stuff and a lot of options I can do if I want to, but tell me more about this S5D9 MCU that's in this platform.
The S5D9 is a ARM Cortex-M4 processor. It has 2 megabytes of code flash, and it can run at 120 megahertz. And all the various components such as analog A to D, timing control, HMI, also comes with various security encryption, safety, power management, even connectivity options such as connectivity stacks for Ethernet, serial communication interface, and various other external memory interfaces. So all the kind of pieces you need as you would expect from a microcontroller.
So we've talked a little bit about cellular, but what is the full set of connectivity options the kit supports? Now, I assume it's not just cellular, right?
It's true. So while cellular gets a lot of as sort of the new technologies out there, between you and me and Amelia, I have a lot of customers that love cellular. We go into them and they say, yeah, give me cellular. And when we actually go to help them do the design, they're like, actually, I just need Ethernet. So there's a tension of that. Cellular, it's sort of like your sexy, Cadillac kind of eye candy. Everyone wants that. I always want the dream, but sometimes I'm living in a mid-sized compact car-sized world. Nothing against those connections. Sometimes that's how it works. But the great thing about the AE-Cloud2 kit is that it can support all three. So if you want to start with cellular and you want to evaluate it, if it's a great fit for you and your application, excellent. We have that available. For other people, Wi-Fi, because you're in an environment, that's what you need, or Ethernet, perfectly acceptable as well too. So we knew that IoT, people need options. So we try to cover some of the major three options, connectivity-wise, that people can use and use to build their products.
Got it. Okay. Now with cellular, because we're doing RF, I know that there are a lot of regulatory issues and hoops we're going to have to jump through, right?
So, Amelia, I'll be honest with you. When I started on this project, I knew absolutely nothing about RF certification. And let me tell you, it is like drinking from the fire hose, proverbially speaking. Just between you and me, the engineers that have built this, I'm in awe and impressed by them, the hoops they went through. So what I've learned is that, when you do RF certification, which the AE-Cloud2 kit has, part of the reason you do certification is it's a sign of quality. A lot of times we don't think about that, but that's what a certification does. It says, hey, this is complied with a certain set of standards, and it's also regulatory, or even basically someone has bothered to put the effort to make sure it checked out and worked correctly. So when we talk about RF certification, usually what has to be done is make an embedded device. Typically what you do is you're going to go to a agency or body or test facility to get the certification done. But before you do that, because you want to be prepared, as I always tell people, it's like running the 100-meter dash in the Olympics. It's years of training for 10 seconds of running. So kind of that's what we have here. Sometimes a lot of preparation has to go in, where basically you'll do what's often called a pre-scan. So you'll run a simple test just to make sure, hey, what's the profile in terms of the RF characteristics of my board and device? And then depending on that, if your own self pre-scan, if it passes, great. You can probably go to the testing house and get it certified and move on. But if not, typically, and it usually doesn't on the first pass, then you're back in the classic engineer cycle of test, debug, test again, and kind of troubleshoot. Because oftentimes what you're having to find is that there's often RF noises being emitted from the board, and you have to find out where the source is. And, as you and I have kind of talked about a little bit, that sometimes the RF noise is a little bit like black magic. You don't always know where the holes in the dike are coming from, so you have to kind of keep plugging the holes and make sure that you're not emitting noise unnecessarily. Usually what will be happening with that is sometimes you'll be adding RF shielding, or you'll have to add more grounding, or you may even have to modify the PCB to address those noise emission issues. So again, when the process is done, someone always stands back and says, oh, how hard was that? You just had to put some components on there. But as anyone that's actually ever done it, going through those pieces and kind of going through step by step, and anyone that's ever done troubleshooting, when you're in it, it's just as if you're at the bottom of a dark hole. You're never going to see the light of day, but you can get there. But the good news is, we went through all that pain. Our engineering team did a really great job and really put the time and effort in to do that, to save customers that benefit. So globally, the kit can be used, and because it has those certifications and qualifications.
So what are the certifications and qualifications that you guys have done with AE Cloud?
So in addition to some of the wireless and RF, so in the US, we comply with the FCC standard. Also for Europe, we have complied with the CE standard, and Japan MIC for that region. In addition, we also comply with standard RoHS and WEEE compliance for electronic waste and other kind of materials qualifications.
Okay, so beyond the circuit board, what connectivity stuff is included in this kit?
For the kits, in addition to the MCU board, as I mentioned, there's a cellular Arduino shield that comes with it, included with the kit as well. And then one thing we found out is, we've done some other tests with cellular, and as anyone who's had bad cell coverage on a phone will tell you, the antenna makes a whole lot of difference. So you remember a couple years ago, there was an issue with, certain, we won't name the manufacturer, but, certain phone, if you held it a certain way, the antenna didn't work, So antenna design was kind of important. So we recognized that we try to include a decent sized antenna. Obviously, we're not going to stick a 20-foot tower on there, but try to give you something to get you started of decent quality, and especially want to call out the GPS antenna. I've used kits in the past that have GPS on there, and it's just almost worthless because there's no antenna. I'd be lucky if I got a GPS signal, basically. So we've tried to include a reasonable GPS antenna to help improve your chances of being quality, that you can get a signal and location of where the kit is.
Okay, let's say I've got my kit. Now, what are some of the things that I need to do to get going with my design?
So number one is like anything, you have to go ahead and get a kit with the part number listed there. And the second step is you're going to download the Synergy software package. That's the software component that's going to drive the microcontroller, the Synergy S5D9 microcontroller. And that Synergy software package, or SSP as we call it for short, includes, RTOS, includes networking, security, and connectivity software. So all those pieces that any IoT developer is going to want to think about and include and have as part of their solution. And after that, that's what you're going to use to build it. Now, to help people get a sense of, rather than just throw a kit and software at people and say, good luck, go forth and build IoT. So what we've gone ahead and done is we've also built some demos and application projects that can help people visualize and see what can actually be done with this kit.
Okay, so tell me a little bit more about these demos or reference designs and so forth.
For a demo, we have the Synergy Enterprise Cloud Toolbox that allows someone to take the AE-Cloud2 kit and connect to the cloud service providers from Amazon Web Services, Microsoft Azure, Google Cloud Platform in as little as 10 minutes. The Enterprise Cloud Toolbox demo comes with a built-in web dashboard, all free of charge, that you can quickly take the sensor data from the AE-Cloud2 kit and visualize it on the web dashboard. So the way it would work, as seen here on the slide, you'd connect a Synergy kit, get a Synergy kit using Wi-Fi, cellular, Ethernet, choose the cloud service that you'd like to use. We have a password-protected web dashboard that you can log into, that you can see the sensor data and also even control some of the lights and other components on the kit.
Okay, cool. Tell me more about that.
Yeah, so the Synergy Enterprise Cloud Toolbox, we deliver it as a binary example, comes with a quick start guide. And like I said, it connects in 10 minutes. You can choose from Amazon, Microsoft, or Google, or switch if you need to after you decide you choose one, want to try the other one. And as I said, the software executes on AE-Cloud2 kit, and it's going to use MQTT and TLS to connect to the cloud that you choose. MQTT and TLS are pretty common protocol and software stacks that a lot of IoT are using these days. And again, we mentioned quickly going to compare cellular, Wi-Fi, or Ethernet. And it's all using the frameworks that are part of the Synergy software package. So we have the software that drives all those components to make that easy to use. And again, visualize the sensor data, a private web dashboard. So there's a username and password. So no one else can see where, if you decide to take the kit when you go visit your mother-in-law in Timbuktu, no one will know that because it'll be password protected and behind the kind of login. And then actually, it's a great way to demo it just for yourself, even if you're just evaluating it, or just to show off, and maybe you could take it and build your own application.
Cool. Okay.
So also, the main component of the AE-Cloud2 kit is the cellular portion. So we've also put a lot of effort into trying to help people with the cellular. So the Cloud Toolbox demo, it also comes with a command line interface. We've gone ahead and checked the kit using certain carriers from various regions all over the world. We've gone ahead and done some basic testing so that we have a list of pre-configured carriers that we have the settings and configuration in the command line interface. So if you said, I'm in this particular region of the world and I see there's a carrier that I recognize, and I just enter that number on the command line interface and boom, there you go, you're connected. Now, if you came to me and said, hey, Jason, there's a new carrier that either came out after the kit came out, or, I don't see the one I'd like to use listed here, we also have a manual method that if you can, for those familiar with cellular modems, you can enter the AT command sequence and basically onboard to your local cellular provider. So if you have someone there that pre-configured and is there, great. But if you have another carrier that either another one you want to evaluate or it's just not listed, we also have a pathway for that as well, too, to use that. And also, again, all that information sent to our Cloud Toolbox web dashboard, so you can see all the things like air quality, light, location, all that great information. And the other nice thing about the kit is once you set it up, if you store the cellular settings and they're working correctly, the kit can also automatically come up. So if you set it up once and you want to keep using it, you don't have to go to the command line interface every time and keep re-entering it. It's a set it up once, get it running, and then you can just keep power cycle and it'll keep running until you want to change it again.
Cool. Okay. I like the global applicability of this kit. That's really nice. So say I've liked the demo and I want to get started with my own code and get connected to a provider and so forth. What do I do?
So to help people get connected with source code, we have our cloud application projects. And we have individual projects that show off how to use MQTT and TLS that are part of the Synergy software package. And we have different projects to connect to Amazon, Microsoft, and Google individually. Because, so customers have told me, and I think most people would understand, while it's great to show off connecting to all three cloud providers in one demo, I've yet to see any customer that picked all three. It'd be the worst case of indecision I've ever seen. But we have code that helps with each of the individual cloud projects. And these are source code that we're putting out there and we're standing behind, that Renesas is putting out there. So this isn't just some sort of open source project we just kind of an intern threw together, we just slapped out there. We've put a lot of engineering time, effort, and thought and really put these out there to make those available to help people begin to build their IoT projects to connect to these specific cloud providers.
Now, Jason, if I have a smaller team with maybe not as much expertise and I want to just get going easier and faster, how can you help me out?
We definitely can, Amelia. Some of the large cloud providers that we mentioned are great for some enterprises or people that are at least willing to invest the time and engineering effort to kind of build up those solutions. Very powerful, very capable, not taking away anything from those. We recognize that some people just either due to time, budget, expertise, you name it, sometimes they need a cloud solution that can help them get started a little more quickly. And so we have a project from our partner Medium One. They've written a project for the AE-Cloud2 kit. And they also provide tutorials as well too. And it connects the Medium One sandbox environment for Renesas kits that basically can allow you to quickly put your data into their cloud. And they also have pre-built web dashboards that you can start with to visualize your data. And if you're ready to go to production, you can easily take their information from the trial starter sandbox and shift it over to the production environment very seamlessly. So it's a great option that if you're more constrained on the engineering or you're just not as familiar, another scenario, it's a great way to just kind of get started in that front.
Okay, cool. Now let's talk about the software side. What software components or frameworks or stuff like that are included to help me build my application?
So when you're ready to start building your application, we have, as I mentioned, the Synergy software package, and that includes things like a file system that can access your QSPI or NOR flash. Even if you want to do a touch panel, we have a framework that can support that as well too. And as we've been talking about during this presentation, we have a cellular framework for support for the Kectel BG96 modem, and specifically has support for the NB-IoT and Cat M1 technologies. And that's what we're going to use to send the commands to the modem and kind of handle those drivers. Additionally, we also have security is pretty key. So we also have our RSA 4096 encryption and decryption and digital signature verification. And also we have support for TLS and for 1.1, that's what we added at this version of the SSP that we're delivering. And also HTTPS, because a lot of our internet connections are basically sent using the HTTP protocol. And lastly, we also have added support for DHCP as well too, for those that need that.
Awesome. So circling back to the cellular side a little bit, how does the cellular framework help me build my application better or faster or different than I would otherwise do?
So when we think about building any kind of cellular application, typically we're talking about a microcontroller that's connected over a serial interface to a cellular modem. That's on the physical side. On the software side, typically we're going to have if someone's going to write application code. In addition to application code, they're going to need an IP stack in terms of making the internet connection. And also they have to write the drivers to support the cellular modem. How is the microcontroller going to communicate with the modem over the serial interface? And the challenge with doing that is the cellular modem is going to affect all the layers of the application. It's going to, for how you're going to connect and how your application code going to affect all those pieces. It's deeply kind of integrated or embedded when you write that code. Also, it can be really large and invasive, and it can be difficult to change. So it's a central part of your code, your connection that's happening. And if you ever want to make any changes or anything needs to be redone with it, there's a lot of rework that has to be done. With the cellular framework, again, the physical components will stay the same. So you'll have a Synergy microcontroller and connected over a serial interface to a cellular modem. And then what we've done is we help modularize or segment out some of that functions. So you're still going to have application code, but your IP using the NetX Duo IP stack, that's a separate layer that's out there as well too. And the cellular framework is acting an extra layer of abstraction so that the cellular modem driver that you write can be separated from the rest of the code. And if you ever needed to change it due to changing a modem manufacturer or the part goes obsolete, God forbid, that, the driver can also be seamlessly removed and redone where all the other code can stay the same. All your APIs, all the other drivers, you don't have deep level function calls to a specific command for that particular modem that you have to use a find and replace in your code and dig it back out and then pray to God that you caught all the places, So it's one of those that helps people abstract and quickly build and create what they need with the cellular framework and get up and started.
Great. I think I've got all that I need so I can go to the Mauser site and download what I need to get started with my cellular IoT application. But Jason, before we go, can you summarize what we've talked about today?
Yeah, definitely, Amelia. So in general, what we talked about is, we have a Synergy solution for LTE IoT. It's really practical and useful to get started with your IoT design. We also talked a little bit about the Synergy platform and the benefits of that, how Renesas can help people do it efficiently. And also one thing I also want to highlight is we're talking about one part number that can be used anywhere in the world to support LTE Cat M1 and Cat MB1 or NB-IoT applications. That's not common. So we're not talking about one part number for Europe and one partner for the Americas and one for Asia, one part number for the entire world because of the certifications and all the pieces. And then also, we've tried our best to include a selection of connectivity and sensors that you can use as a starting point and kind of enough to get you started. And also, we're talking about saving developers time because of software and hardware development. Embedded developers have a lot on their plate to think about. The last thing, think about creating a PCB, getting the sensors, choosing which connectivity option, and then building the software from scratch. That's a lot before you even send 1 byte of data into any kind of cloud. So we want to get people to that point faster. They can begin and build their applications, add their value, not build sort of the basic structure every time. And then also the kit, we've done a lot of hard work in terms of the EMC best practices and RF certifications. We've tried to make the kit something that people can use and benefit and use anywhere in the world. And we've sort of made our best effort for that. And for those that want to find out more information, you can go to the URL listed on the screen.
Excellent. Well, it was a pleasure speaking with you, Jason. Thank you so much for joining me.
Thanks for having me, Amelia. It was a great pleasure and a lot of fun.
And before we go, you didn't forget to click that link, did you? There you can find more information about the Renesas Synergy AE-Cloud2 Development Kit. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talk section of EE Journal. Can't miss it, right across the top. Or head on over to YouTube. Keyword